Hey everyone. So for many years now, I have battled with the default Blender Surface Deform modifier. And the reason for that is because it is very limited in the sense that it will only work on mesh objects, and it will also fail to bind 50% of the time, because if your target mesh contains concave faces, it will just fail. It won't let you use the modifier, and that is just not good enough. It's too unreliable, and that's not great because surface deforming, wrap deforming is a vital tool that you have to have in your tool belt, especially in a production environment when you're constantly getting notes on models and you need to make changes to a character. For example, the body changes, you want to wrap the clothing to the body and have it follow along with those mesh changes. It's just vital, and you have to have it, and it has to be reliable, which is why I have created Mesh Magnet to kind of fill that gap, fill that void, and give Blender users a reliable tool for surface deforming. With that said, let's get started. So, first thing we need to do is select the objects, and lastly select the target mesh, the deforming mesh. We go to Object, Mesh Magnet, and run the Mesh Magnet operator. And we can choose our mode here, so we'll start with Elastic for now. Elastic is basically going to deform and warp these objects along with the surface, which you'll see in a second. So as you can see, it is now following the surface and distorting based on that target mesh. Now, what has this done under the hood? Well, first thing it's done is it's created an attribute on our target mesh. So if we come to the attributes, you can see that there's a new attribute called bind pose. And this is basically storing the position of every single point in its original rest position. So it's basically remembering what it was when it was flat in this particular case. And it's also added a bunch of modifiers to our objects. The mesh magnet modifier, and it's automatically set the plane under the deform mesh, set the mode for us. And it's also important to note that the target mesh should also have a UV map. It's expecting that as well. So let's check out a few more of our operators in the add-on. So if we go Object, Mesh Magnet, select by Deform Mesh, you can see that it will select every single object where this target mesh is being used in the Mesh Magnet modifier. So this can just make selecting hundreds of objects really quick and efficient if you want to just apply the modifier to a bunch of objects. The other one is Clean. So if you select a deform mesh and you click Clean, it'll give you a little prompt here, OK, and that will remove the attribute, and it will also blow away the modifier on all of these objects. So just resetting everything back to its default state, just to quickly clean everything up. The last operator is the refresh bind pose. So what this will do is, because currently the bind pose is remembering it in this flat state. So if I did make some mesh changes, and I want this to be the new bind pose, I could just come here and refresh bind pose. And that will update, and it will now, this will become the rest position, the default state that the modifier is going to reference before deforming. One other thing just to mention is that when you run the Mesh Magnet operator, it's going to check if a attribute exists or not. If it already does, it's just going to leave it as it is. But if it doesn't have the attribute, it will create it for us. So this is basically the tool we use to update that bind pose on the target mesh when we need to update it. Another really important thing that should be noted is that if you look at the pivot points of all of these objects, they're matching the pivot or origin of the target deform mesh. So we have the exact same transforms as the target deform mesh. That's really important for all of the modes except the rigid mode, which we'll go into in a second. It's also really important that the deform mesh, the target mesh, has its scale and rotations applied. It's okay to move it in space, but you can't have rotations on the object. You need to zero out the scale and rotations to get expected results on all of the modifiers regarding that. Great, let's move on to the rigid deform mode. So we'll just bring up this collection here. We've got a bunch of objects, and you'll notice that the pivot points of all these objects are, they're all relative to the object, right? They don't need to match this particular deform mesh. Whereas all the other modes, it's important that the pivot of all the objects matches the deform mesh. So without harping on, let's just see what happens here. If I run the mesh magnet operator and set that to rigid, and now you can see what's happening here is that the objects are not actually deforming or warping. They're maintaining their shape, but they're just being pinned to the surface. And you can imagine this is very useful for, let's say you have a damaged vehicle and you want the rivets and bolts to follow along with the panels as they kind of bend and deform. Or if you've got buttons on a shirt, for example, and you want to wrap the shirt organically using elastic, but the buttons you can set to rigid so they don't get all warped and deformed, as you wouldn't want that to happen, right? Moving on to groom. So we've got a bunch of guide curves here. If we run groom curves in the mode, and we just deform that, you can see the guide curves are following along, which is perfect for transferring a groom from one character to another, for example. And the last mode is scatter, or procedural, basically. So with these objects, I've just got a procedural scattering system going on where these are all instances. And once again, you can see that the origin is matching the origin of the target mesh. And we'll run the last mode, which is instance procedural. And you can see that these are also following along with the mesh just fine. So that might be very useful for an environment where you have lots of things scattered on the surface, for example. And you don't want your points to be redistributed as the mesh changes. You want to have consistent scattering, and this could help with that. Great, and the last thing I wanted to show is that you can actually deform curves as well. So we'll just run the mesh magnet operator again, and as you can see, curves are supported by rigid and elastic, but we'll just use elastic for now. And you can see that these are following along just fine. And that pretty much summarizes Mesh Magnet, just a simple, effective tool for surface deforming objects, and it's reliable, robust, it can support many different object types, and trust me when I say it's something you must have in your tool belt as a 3D artist. And Blender's default surface deform just doesn't cut it. So if you think you'll find this useful, you can find it on my Superhive or my Gumroad page. Alright, thanks, bye.